Hey everyone, welcome back to another session in this AP Calculus AB and BC course. And today we are going to start Unit 7, which is differential equation, which weighs around 6 to 12% for the AB student, 6 to 9% for the BC student. For one-to-one tutoring or group session or regular sessions, you can connect with us on this number using WhatsApp or Telegram and book your free demo. If you need any other detail, please feel free to connect with us in the comment box as well. Okay, so in the differential equation, we have the following subtopics. Like they will give you a situation where you have to create a differential equation using that, right? And solving the differential equation by various methods and sketching the slope field, right? And also like solutions using the numerical methods. One of them is Euler's method. Okay, so let's start with the differential equation and its solution part. So here in this session, I will tell you about how to solve a differential equation using the method of variable separation. Okay, so let's start with that one. What do you mean by variable separable method used for solving a differential equation? Basically, they will give you a function where dy over dx will be given in terms of some x and y such that fx and gy can be separated by using cross multiplication only. If you can do that, it means yes, variable separable method is working. What I'm trying to say is, if by simple cross multiplication, you can separate the x terms on y one side and y terms on the other side, right? Then we can use this variable separable method, which says after doing this, after separating the variable, simply integrate the function. And that's it. Use your normal integral methods, you will get your answer for the solution for this differential equation. They may ask you to find the general solution or the particular solution. Okay, so for the particular solution, general solution means you will get your answer in terms of C, constant of integration. But for particular solution, they will give you some boundary condition or initial value condition, right, where they will give you some points lying on that curve, and using that you can find the value of C. It means there is no constant of integration in the particular solution. It's a complete solution without any constant of integration. Okay, so here let's start with a problem, which is dy over dx is equals to x squared times 1 plus y over 3. Now, your first step is always to check whether by using simple cross multiplication, can you separate the variables? If yes, go for the variable separable method. If not, then go for the next approach. So here, if you see, yes, we can do that this time, correct? If I take this 1 plus y on the left side, so I will get 1 over 1 plus y dy is equals to x squared over 3 dx, right? By simple cross multiplication, we separated the variables. Now, means we can use the variable separable method, and integrating the function gives me the answer. So, now integration part. 1 over 1 plus y with respect to dy. What is the integral of 1? You can either use u substitution here, or simply you can use the linear formula, right? Because if there is a linear change in that, I'll write here the integral of 1 over ax plus b dx is simply natural log of ax plus b divided by a, the coefficient of x in this case, plus c, where c is the constant of integration. So I'm going to use this result. Okay, so that gives me the coefficient of y is 1 here. Okay, so I will get natural log of 1 plus y, that's the integral of left hand side. You don't need to add two different constant of integration. No, just add one only on either side. Now for the x squared by 3 part. So for this x squared by 3 part, can I write it as what? Integral will be x cubed by 3, and already you have 3 in it. So plus c, where c is the constant of integration. So now here you have a choice, right? You can add any constant of integration here, either plus c or natural log of c. That's totally up to you. So here I will add natural log of c as my constant of integral. Now let's solve for y. So here we have natural log of 1 plus y minus natural log of c, by taking this natural log c to the left side, equals x cubed by 9. Now here I will use the property of logarithm on the left side. Log a minus log b, which makes log of a by b. So 1 plus y over c is equals to x cubed by 9. Now from here I will get 1 plus, using the definition of the logarithm. I'll write here. First I used the property that log a minus log b gives me, okay, natural log of a by b. And now I'm using the definition of logarithm in the next part, which says if you have log of a to the base b equals to c, then it means a equals b raised to the power c. And you know already that ln of x means the base is e. Log x base e is the another way to write natural log x. Okay, so here I have the same kind of situation. This 1 plus y over c is the a part in the, okay, so I will use the definition. This is definition of the logarithm. 1 plus y over c equals e raised to the x cubed by 9. That gives me 1 plus y equals e raised c times e raised to the x cubed by 9, and we got our answer as y equals c times e raised to the x cubed by 9 minus 1. Right, this is my general solution because it contains c is unknown, right, constant of integration. So this kind of solution is called general solution because they are not giving any information about x and y values, so we cannot find c in this case, means there is no particular solution for this particular problem. Okay, so this is our general solution. Okay, now in the same question, if this is, if the solution passes through 0 comma say 3, then what is the particular solution? So I will use the same general solution and use x equals to 0 and y equals to 3. Okay, so use that. So what you got? 3 in place of y is equals to c times e raised to the 0 minus 1. So what is that? That gives me c equals 4, correct? Yes. So if c equals to 4, means we got the particular value of c, and hence we can write the general, so particular solution for this problem. Means y equals 4 times e raised to the x cubed by 9 minus 1. This is particular solution because we obtained this for a particular point, and there is no constant of integration in this. It is particular solution. Okay, so that's the difference. They will always give you a point or some information to find the particular solution. Otherwise, you can leave your answer to the general solution. Okay, now next is Euler's method. As I said, sometimes it is not possible for us humanly to find the solution for every differential equation, right? So we can use these numerical methods for those. So here we are just starting with this Euler's method. We have other methods also which gives us more accurate solution. But in the beginning for AP calculus, we have this Euler's method. Let's start with this one. Euler's method, it's simple. What they will give you is a differential equation, right? And dy over dx is equals to some, let's say, function of x and y. Okay, so this is gradient which is already given to us. Okay, I'm not saying always you have to use this method when you don't know how to solve the differential equation. No, they will give it to you in the question that you have to use Euler's method particularly for this question. Then only you have to go for Euler's method. Okay, so Euler's method is one of the numerical method. So dy over dx is equal to f of x y. Its gradient is already given to us, and what they will give you is they'll say they will give you a initial point. Okay, so x naught and y naught will be given to you, and they will ask for some x and yn. X and yn, this will be given to you, and they will ask for x and yn. Basically, they will ask for yn value for the given xn that you have to find. Now, what is n? How many step size you have to take? Okay. So basically, they will give you these values, and you can easily find the value of step size. Step size, you can write it with h or delta x or h simply is given by the final x value xn minus x naught whole divided by how many step size you have to take. That they will give you in the question, okay, or they will give you step size. Either they will give you delta x value or they will give you n value. One of them will be given to you, but that is the relation. Okay, so how to find the solution? Basically, they will give you one point, right? X naught, y naught, initial point. And using this point only, as well as using this gradient function only, we can find the next value. Basically, y1 will be given by previous y naught plus the delta x times the gradient. Basically, f of x naught, y naught at that point, previous point value. Simple, so simple. So always you have to use this result. Means if you have to find the y2 value, the next y value basically, that will be given by previous y value and gradient at previous point. So basically that is y1 plus delta x times f of x1 y1. That's it. So in this way, basically it is y2 minus y1 over x2 minus x1. That is the gradient value dy over dx when this tends to 0. I'm using the same thing only. Okay, that is the base of the Euler's theorem. So here let's write a result. So the result says the y value at n plus 1th point will be given by previous y value, which is yn, plus h times the gradient on previous point. Okay, previous point we have to use. Remember this. Okay, so let's start with a question. Question is, if the points 1, 3 and 4, c are on the solution graph, dy over dx is equals to x plus y over x, then approximate the value of c using Euler's method and 3-step size of length delta x equals to 1. So this time they are giving you 3-step size, right? 3 steps you have to take of the size delta x equals to 1, basically. Okay, so we have n value as well in this case. Okay, that's easy for us now. So we have n equals to 3, means we have to make 3 iterations. Delta x or h value is already given as 1. Our starting x naught value is what? 1, and final x value xn, which we have at which we have to find the y value, right? That xn is 4. Using this information, I got this. Now, f value. F, what is f? F gradient xn yn will be given by this xn plus yn over xn. Simply, please note down these and then I'll start the solution. Is it okay? So, let's get started with either you can go for normal calculation mode, or you can also use the spreadsheets to get your answer. See, if you use spreadsheets, okay, you can make 3 different columns for your solution. So here I will start with this is, let's say, x values, okay, xn. These are yn values, and here we have f values at that particular point, xn, yn. Okay, so when n is equals to 0 means x naught value. What is x naught? Already given as 1, right? And y naught is also given as 3. So we can also find fx and yn, right? So what is that? Our f at 1, 3, because fxy, let me write fxy also. Fxn yn is equals to xn plus yn over xn. So for the first part, we can do it directly, which is x naught y naught which is our function gradient value at 1 comma 3. What is that? It is coming out as 1 plus 3 over 1. Simply 4. Okay. So we got this value directly. 1, 3, 4. Now we have to start from here. N equals 1 or n equals 2 and n equals 3 we have to take, right? So you can just drag it. It is 1, 2 and 3, 4. Okay, you just drag it and you will get 1, 2, 3, 4 already. Now we have to find this value. So here you can use the formula. Here you can use the formula. What is that? So apply the formula. It is yn, this one. Okay. So we are looking for this value. So simply in your GDC, you can put equals the previous y value. So I will write it as b1 plus delta x is already known to us. So enter the same delta x, which is nothing but 1. Okay. So 1 times f value, this one. So that you can use as, make bracket, we have b x no x1 b1. So that is a1 plus b1 over x value, which is a1 simply. Okay. I mean, I'm using this value, which is a1. This cell is for b1. So a1 plus b1 divided by a1. So once you enter this, you will get the value over here. Okay, means the y1 basically. Y1, which comes out as, in this case, it is coming out as 7 once you solve it. Okay, now here in the third cell here, for this part also you can use the formula. So I'll write the formula for this part as well. What is that? Here you can use equals that, in this case, what is that? B2. Okay, so A2 plus B2 divided by A2 and enter this. When you enter this one, you will get the solution over here. I'm telling you each and every step. Okay, please make sure that you get this. Now here, once you do this, you will get this value as 4.5. Okay, that's it. You just need to find these two values using these formulas. Now you can simply drag this. Okay, go to this and drag that. Once you drag this, you can fill the remaining cells over here. Once you do the same here, you can fill these cells automatically. If this is, you have to use 10 iterations. So with calculator, it's very easy for us to do that, right? You just need to find the first value, okay, and then you can use the drag option to get the solution. So once you do this, you will get the values coming out as, at 3, y value will come, next y value will come out as 11.5, and this value comes out as around 29 by 6, and the answer what we are looking for comes here. What is that? Basically it is around 16.33, and that's my answer. So using the GDC we got this value. Okay, so if GDC, basically they will allow you to use GDC. If spreadsheets, you don't want to use spreadsheet, you can find each value separately. Okay, means you can start with x1 y1, x1 y1. So for x1 is equals to what? 2. You can use f x naught y naught, which is 4, and then y1 value will be y naught plus delta x times f of x naught y naught. If you use this, you will get your answer. It takes time to do it in this way, right? But calculator gives you much faster answer. Okay, so in this way you can solve a question. Next part, limitations. What are the limitations evident in this approximation? So the thing is, what do you think? What a limitation is there in this particular example? Actually, the limitation is this: delta x equals to 1. Delta x equals to 1 is a very large value. We tries to take the step size as small as possible, but it was already given to us in the question. So if we make it as small as possible, we will get better and better result. Smaller is the delta x value or step size, better is the approximation. Okay, so this is actually the limitation of this method. We if we take the higher value of the step size, we do not get a better solution for that. Okay, so in this way you can solve using the Euler's method. So here I'm giving you a few questions that you can try all by yourself, and if you have any doubt in these, feel free to connect with me, and see you in the next part. Thank you for watching this. Keep watching, keep learning.